Good morning, sir. Myself Likit. Today, me and my teammates are going to explain about AI in stock market. Basically, we are going to apply AI applications in stock market which help us to gain more profits while investing. In order to do this, we have done pattern recognition using transfer learning, and then we have done stock recommendation. Here we have built models like decision tree and random forest and we have chosen model with good accuracy. And then we have done stock prediction using LSTM. And for all these models, we have also given code explanation in this presentation. Now let us see why we need pattern recognition. When you are investing in stock market, you can't see candlestick patterns all the day, and identifying which pattern it is very extremely difficult. Some candlestick patterns help us to get more profits. I will tell you why we will get more profits. Here you can see this is the chart taken from TradingView. We have highlighted some important patterns here. Here you can see bullish spinning top has occurred and the trend moves upward, and then inverted hammer occurred and the trend moves downward. Like this the trend moves upward and downward depending upon these candlestick patterns. So these are some important candlestick patterns that we have noticed in the chart. Now, there will be so many candlestick patterns in the stock market, but we have taken frequently occurring candlestick patterns for our model building. So these are the frequently occurring candlestick patterns. So the first one is hammer. It looks like a hammer shaped one, and the inverted hammer, it is like inverted hammer shape. So you can clearly see here, and then hanging man. So it will have less wick when compared to the hammer, and then shooting star and dragonfly doji. It looks same like dragonfly, and then gravestone doji, and these all are the frequently occurring patterns that we have noticed. This slide explains when each of the candlestick pattern is formed and what happens when they occur. For this project, it is not needed to know when these patterns are formed. If you want to know about them, pause the presentation and read the slides. For now, just remember the pattern and the future trend, because the future trend is used to know what happens in the future. So if hammer occurs, the future trend will be upwards. Similarly, if hanging man occurs, the future trend will be downwards. Like this, we have listed all the patterns and the future trends for all these eight patterns. For data collection, we took images of these patterns. For example, here I have given the chart that is taken from TradingView. Here you can see there are some important patterns. So we have manually taken screenshots of these patterns and we have cropped and we have collected these patterns for model building. For training data, we have collected 10 to 15 images of every pattern, and for testing, we have collected 5 images of each pattern. Now let us understand what is transfer learning. Transfer learning is a machine learning method where a model developed for a task is reused as the starting point for a model on a second task. That means, let us consider you have two problems to solve. First, we have sent one problem to the model. The model will learn some knowledge from the first problem, and it will try to solve the second problem by taking the knowledge from the first problem. So this is known as transfer learning. We use CNN model for pattern recognition, which is already pre-trained. The model name is VGG16. It is taken from image.net competition. Why we have taken this already pre-trained model means we can't able to build a CNN model uh, without processing power. So usually CNN model takes huge processing power to build. This is the VGG16 model that we had taken from image.net competition. Now we had removed the input and output layers of this model, but we had kept the weights as constant because this is a pre-trained model. Now we had inserted our input layer as our patterns, which are in the form of images. Now the output will be as whether it is hammer or inverted hammer or any of these eight patterns. So this is our CNN model that we had built from the VGC16 model. Now let us see code demonstration.
Now let us see the code for pattern recognition using BG16. So the code starts like this. Initially we imported some layers and applications and some pre-processing methods that are available in TensorFlow Keras, like input, lambda layer, dense, flatten layer, etc. And we also imported applications like VGG16 to get the weights of the VGG16 model. So now we set the size of the images to be 244 cross 244. So we initialize the size is equal to 244 cross 244. We have the images, that is training and data, training and testing data in our Google Drive. So we also imported Drive, and we initialize training data as the training images and testing data as testing images from the Drive. Now, VG16 is already a pre-trained model, so no need to train it again. So we initialize VGG as the VG16, which is from the TensorFlow Keras, and uh, what we did is we removed the input layer of the VG16 and output layer of the VG16, but we have the hidden layers with the weights trained from VGG16. VGG16 has it is from ImageNet competition. It has thousands and thousands of input images and prediction of that. So we removed the input layer, and we kept the size of the input layer, that is 244 plus 244 by 3, that is RGB color. So that is color images, and weights are like of from ImageNet competition. So for here we wrote for layers in VG16, layers to trainable is equal to false. That means no one, we are not training the model. It is already a pre-trained model. So we are just using the weights of that model in order to do our project. And then we did x is equal to flatten, that is a flatten layer. Then we used activation function for the output layer, and this is a basic summary of the model. Here we could see we changed the input layer, and rest all hidden layers are of VGG16, and lastly we changed the dense layer, that is the output layer. Then we compiled the model with categorical cross entropy, that is for multi-class classification, and we use the optimizer as Adam. Next, for the image pre-processing, we used image data generator. Like image data generator is mainly for data augmentation. So here we can see image data generator. So it creates a multiple images, it creates multiple images of our training and testing data. Here we did that, and from there now we built the model uh, with the training data and testing data, like validation data. We just did 7 epochs. In the 7 epoch, the accuracy reached exponentially to 97%, and hence the model is performing well.
Hello sir, myself Pranay, and I am going to take you through stock market prediction and recommendation. Now let us look into stock market prediction. Predicting the future worth of business stock is the main aim of stock market prediction, and the ultimate thing is to gain profits from the stock market prediction. But it is quite difficult because there are various factors involved in this, like physical and psychological ones, and it might behave in a rational or irrational way. All these forces work together to create a volatile and dynamic market for shares. That is why it is quite a bit difficult. So this is the preview of the dataset, and this dataset is extracted from YFinance library, and the columns are open, high, low, close, and date. Open describes the opening price of that particular date. High means highest price, low means lowest price, and close means closing price. The dataset is taken from September 2007 to December 2022, and this analysis is only performed on closing prices. We have used LSTM to predict the stock prices. This is the structure of the LSTM. We have used LSTM because it can remember the memory for long time compared to RNN. The more data we have in stock market, the more accurately it can predict. So this is the memory cell, this is the forget cell, this is the input layer, this is the output layer, and these are the activation functions: sigmoid, tanh, and tanh. So this is the LSTM methodology. The data has been splitted through train test split with a step size of 45. We have trained the model with the specifications given in the picture on the right. And the model got trained for 55 epochs. And we got a loss percentage of 6.3. This is the original Nifty 50 chart, and this is the comparison between our original chart and the predicted chart. Now let us look into stock recommendation. Initially, we didn't have any data set. This is the firm recommendation data set extracted from Y Finance. It contains some firms like Argus Research, Hilliard Lyons, Morgan Stanley, and these are the recommendations by those firms like buy, long term buy, overweight, outperform, neutral, etc. And we have extracted another data set called stock news data from kaggle.com, and these are the firms, same firms, UBS, and it contains some news, and it also contains the recommendations. Now what we did is we have concatenated these two data set, and that is our final data set for this recommendation. This is the methodology for stock recommendation. Firstly, we concatenated the dataset, then we performed the data pre-processing, then vectorizing the dataset, bag of words and TF-IDF, then we built the model, and the model with best accuracy is taken. Now, let us see the code demonstration for this stock recommendation and prediction.
Now let us see the code for stock price prediction using LSTM. Previously in the presentation we have seen why LSTM is better than RNN and stuff like that. Now coming to the code, the data that we have in Yahoo Finance. So initial step is to install Yahoo Finance. Next we imported some libraries for pre-processing and for stuff like that, like NumPy, Pandas, Matplotlib to plot. So from Yahoo Finance, this time we imported the data of SBN. Here you could see the data of SBN. Now we mainly worked on the closing price of the SBI. So we took only the closing price, and this is the plot, the original plot of the SBI, and we'll also plot the predicted price. Here it will show in the upcoming code. So the next step is pre-processing of the data. We used min-max scalar to scale all the values in the closing price of SBI, and then we did train test split. Here the train test split we do in a different process because this data deals with time. So here we use step size and timestamps. In that way we divided the train test data. So these are the data points of training data and testing data. The similar way we created the training data and testing data and their outputs. X is the input data and Y the output data. So in the project we initialized the steps as 45, and then we splitted X train, Y train, X test, Y test. So these are the stages of X train data and Y test, Y train data. Then we built a model. We use TensorFlow, sequential model, dense model, simple RNN and LSTM. So we built an RNN model, but the accuracy of RNN is too less, so we used LSTM. So now this is the part where we built the model. So initially sequential model, then the first layer is of LSTM with 52 neurons, and the size of the input is 45,1. Here we could see 45,1. So the second input layer, again it's an LSTM with 64 neurons, and the third model is also LSTM with 50 neurons. So When these LSTMs are continuous, we can say this as a stacked LSTM model, and then we added a dense layer for the output. Then we compiled the model with mean squared error to see the loss of the model, and we used basic optimizer Adam. So this is the basic summary of the model. We could see input layer, output layer. Then we trained the model using xtrain, ytrain, and the validation data as xtest, ytest. We took 50 epoch, and each batch size as 64. So after the 55th epoch, we saw that this much of loss. The error is too low, mean absolute error. We could see 0.0044 is the loss. That means we can tell that the model is performing quite well. Then we predict the training and testing data. So this is the length of the testing data. So to plot it, we actually scaled down the data. So we need to reverse scale the data and plot it. So this code does the reverse processing, reverse rescaling of the data. So we could here we could see the prices, and then we plotted the like predicted prices. So this is the zoom version. Like we zoomed to 2 to 3 months, and from this point the price increased. So this is actually the predicted price, and this is the actual price. So this is the whole image of the data. So SBI, from here till here it was the like given price, and from here it's the predicted price. So I think the model is performing. Let us see the code for stock recommendation. As we told before in the presentation, we don't have a dataset, so we created our own dataset. For the recommendation dataset, we took it from VFinance, so we imported VFinance. Here we can see we took the recommendations of Microsoft stock, and these are the firms that were recommending the stock to buy, or depending upon the market situation, they were giving their recommendations. We imported some basic libraries like NumPy, Pandas for obvious data pre-processing, and this is the dataset. Then in recommendation.csv, we have the stock news during that period. So we merged these two datasets of the recommendation dataset and the news dataset. Then basic pre-processing of the data. Then this dataset, that is the dependent value, has like output like buy, equal weight, hold, etc. So we did one hot encoding. Then we split the data into independent and variable set, dependent sets. So X, we could see the news, that is an independent set, and Y, which is the output, is a dependent set. Now we need to do data pre-processing on the independent set. Since it is a text, we thought using NLTK. NLTK has many tools, so we use that. And here we could see to remove stop words, and for stemming, this code snippet does that work. After that thing, to change that into vectors, we used bag of words, that is count vectorizer, and df. We'll take that vectorizer, which gives the more accuracy of that model, and we used multiple models like Gaussian naive Bayes, multinomial naive Bayes, Bernoulli naive Bayes, and random forest, as well as decision tree. After all this processing, we found out that the vectorizer, that is TF-IDF, with the model random forest, gives us the high accuracy with 76%, whereas all models perform quite low.